Hi class, let's take a look at example 8. And example 8 could be really messy if you don't recognize the actual shape of it. In this case, because it has a single cosine and then it has a value of 3 multiplying the angle or the argument, this one's going to represent a rose with a total of 3 petals. Okay, so let's start by plugging in a couple of coordinate points. So same as we did before, we're going to be looking at theta, and then this will be r is equal to cosine of 3 theta. Then we're looking at r comma theta. Okay, so let's start with technically, let's do a couple of coordinate points. So let's start with perhaps 0, then pi over 2, then let's do pi, 2 pi over 3, and as long as we get distinct coordinate points, that would be fine. So the first one, when we evaluate 0, this one will be r is equal to cosine of 3 times 0. And this is going to give us just 1. So we're looking at radius of 1, angle of 0. So for this one, if this were to be 1, that would be our first coordinate point. The second one, it's at pi over 2. So this will be r is equal to cosine of 3 times pi over 2. And I'm getting that this is 0. So technically 0 and then pi over 2. So we're looking at, well, the origin. Evaluate pi. And this will give us r is equal to, so r is equal to cosine of 3 times pi, which I'm getting -1. So we're looking at -1 angle of pi. So for this one, remember that you technically graph 1 comma pi first. So let me just put a slash there. This is technically 1 angle pi, but as you add pi to it, it's actually going to put it on the origin again. So let me select the value nearby. So in this case, r is equal to cosine of 3 times 2 pi over 3. So add 2 pi over 3. I'm getting 1. So this will be 1 comma 2 pi over 3. So the third coordinate point, it's going to be, well, this is 1, that's 1. So somewhere around here. Okay, so all of these are standard if you remember what we did in the trig classes. If not, you're basically looking at graphing almost the same graph for a future examination. So this one's going to have 3 petals, and this particular graph is actually going to do this sort of a curvature. And this will be the second one. Whoops, actually it doesn't go below that. So it basically goes in this direction. Sorry, it doesn't loop. So it goes like this, and the last petal, it's going to be in the third quadrant. So not to scale. Okay, and you can keep plugging in more coordinate points. Let me go to the textbook to show you the formulas. That's exactly the coordinate, the exact graph. It's one of these. So technically we're doing the cosine. That's what all of these look like. So for a future examination, if you have a graph, it'll be almost identical to this one. The only thing I would probably change is maybe you could have a constant in the front, which is just going to make it larger, but you're still graphing the same actual equation.